The all-slime cyanidation carbon in pulp gold extraction process is one of the important methods used in the production of gold. Many years of production practice has shown that the carbon in pulp gold extraction process has become mature and improved. This process is transferred overseas, along with export of our mining machinery to serve the global market. The following section provides a brief description of the all-slime cyanidation carbon in pulp gold extraction process. The ore is transported to a crude ore bunker and fed into a crusher by a feeder. The coarsely crushed ore is conveyed to a vibrating screen by a belt conveyor. The coarse ore particles is returned again to the vibrating screen through a two-stage crushing process, and the undersize within the specified grinding particle size range is transported to a fine ore bin by the belt conveyor, and then fed into a first-stage grinding mill and classifier for coarse grinding by a fine ore feeder and the belt conveyor. The coarsely ground ore with the typical particle size of 0.074 mm accounts for approximately 60%. In the first stage, gold particles cannot be finely ground in order to achieve complete monomer dissociation and are not within the particle size range required by all slime cyanidation process. In this case, a hydrocyclone cluster for second stage grinding is used to classify particles and ensure that the particles with a typical size of -0.074 mm account for approximately 90%. The typical overflow concentration of the hydrocyclone is around 20%, and the pulp concentration required for cyanide leaching and carbon absorption is 35 to 45%. So the pulp needs to be concentrated by a thickener. A trash screen is needed to remove the impurities from pulp before concentration, and then the treated pulp is fed into the thickener for concentration to ensure that the concentration of pulp reaches the concentration level required for leaching. That is to say, the thickener's underflow may be pumped into a leaching tank for leaching. The thickener's underflow may be pumped into a leaching tank for leaching. The overflow, clean water, from the thickener may then be returned to an elevated water tank or directly returned to the grinding and classification system feed water for reuse. Cyanide is added to a carbon in-leach system. Then medium pressure air is pumped into the system. An activated carbon is added to the system. The energy-efficient dual impeller agitating tank has impellers operating at lower rotational speeds and higher linear velocities and a low-power motor. So it is more energy efficient and can prevent the loss of gold resulting from the loss of gold-loaded carbon by avoiding the crushing of gold-loaded carbon due to the high-speed rotation of impellers. The pre-leaching process, as well as simultaneous multi-stage leaching and absorption process, ensure that the gold-loaded carbon with a grade of 3,000 to 4,000 grams per ton is lifted out by a carbon lifting pump. The gold-loaded carbon lifted out by the carbon in-leach system is screened and washed thoroughly, and then conveyed to the desorption electrolysis shop for desorption and electrolysis. The gold in gold-loaded carbon is dissolved in liquid through desorption. In the electrolysis process, the principles of anodic and cathodic electrolysis are applied to allow gold or silver to deposit at the anode of an electrolyzer to obtain gold slime. Normal temperature pressure desorption electrolysis systems and high temperature pressure desorption electrolysis systems are the most common desorption electrolysis systems in China. The operating temperature of normal temperature pressure desorption electrolysis systems is maintained at 85 to 95 degrees Celsius, and its desorption duration is kept at 28 to 70 hours. High temperature pressure desorption electrolysis systems do not contain any heat exchangers. They may operate at the temperature range of 150 to 170 degrees Celsius and the pressure of 0.35 megapascals, with the desorption duration of 4 to 6 hours, which ensures high desorption rate and shortened carbon cycle, and helps greatly improve operating efficiency. The barren carbon desorbed from the desorption electrolysis shop is discharged into a desorbed carbon storage tank and then fed into a pickling tank for pickling. The treated barren carbon is then dehydrated and fed into an activated carbon regeneration kiln for regeneration, and is finally returned to the cyanide leaching shop for recycling. The gold slime from the desorption electrolysis process contains about 30 to 50% gold. It is transported to the melt shop and melt using pyrometallurgical or hydrometallurgical process to obtain gold ingots. Tailings from the cyanide leaching process can be treated through alkalization to reduce cyanide level and then directly discharged to the tailings pond for sedimentation and self-purification. Alternatively, in the tailings dry discharge process, cyanide tailings are pumped into the agitation buffer tank in the tailings shop and then pumped into the plate and frame filter press and ceramic filter for filtration using a pressure pump to achieve solid-liquid separation and ensure that the liquid is returned to the process and tailings are discharged through the dry discharge process from a central location. The all-slime cyanidation carbon in pulp process is applicable to low-sulfur quartz vein-type oxidized ores, especially for raw oxidized ores, with an average grade ranging from 3 to 8 grams per ton.